Hey everyone, welcome back to the channel Devotion of Knowledge. Today we are back again with another YouTube video. And if you are following the channel, we did with the three question in the last video in which we discussed left and right view of the binary tree. The video is right now available on the channel. As you can see, this is the video in which we discussed how to find right view as well as left view of the binary tree from scratch. In this video we are gonna learn about top view and bottom view of the binary tree. We are done with this left and right view, so इस वीडियो में टॉप और बॉटम व्यू की बात है। ठीक है, तो सीधे चलते हैं वीडियो की ओर, ज़्यादा कुछ टाइम ना गवाते हुए। तो here I have considered this example. This is the binary tree which is given, and root of the binary tree will be given to us in the function, and we have to return the top view. What will be the top view of this binary tree? Okay, so क्या होगा इसका आंसर? First of all, if we view from this side, top view, if we are viewing from here, what we will be seeing? D, B, A, C, F and H. So our answer will be D, B, A, C, F and H. Here I have considered alphabets, not numbers, so it doesn't matter, concept remains the same. So this node will be the part of our answer whenever we will see this tree from top, or I would say from upper side. Now why? Because see, whenever I am seeing tree for the first time, I will be able to see this node. So it doesn't matter that how many nodes are below this node. It will be acting like an umbrella. If you are watching an umbrella from the top, you will be only able to see the top part of the umbrella. Who is standing below the umbrella at this particular level, we won't be able to identify. So that's the concept which is used here. So if I am able to see A from top side, I won't be able to see anyone which is present on this level, which is E, because E will be overshadowed by the presence of A. Similarly, on this level, B, but there is no one below B on this level, so B will be visible. Similarly, D, as no one is there on the below, so D will be visible. In the case of C, G is visible, but G will be overshadowed because we are seeing from the top. Similarly, F, but no one is under F, so F will be visible. And similarly, H, no one is there, so H will be visible. So this is the approach that we will be considering element which will be occurring on the same level vertically. This is level 1, -1, minus. If we are considering this as a 0, then this will be -1, this is -2, this is +1, this is +2, and this is +3. Now you might be wondering how we can identify these levels. Similarly, if this is the root, if I am going through towards the left of the root, the level will be, well, let us consider the level of this as LVL by variable LVL. If I am going on the left side, I will be just writing LVL -1. So if this is 0, this is -1, and if this is 0, and on this side this will be +1. Similarly, +1 on the right hand side will become +2. Now on this node, if I am going on left hand side, it will be LVL -1, so 2 minus 1 equal to 1. So level of this G will be 1, and similarly on this side, +2 + 1, 3. So yes, that's the main LVL -1, LVL +1. So basically here we have to do nothing, we have to just find the topmost node present on each level vertically. So vertical level means these are the vertical levels as we have seen here. Okay, so we have to just find the topmost element or a node present on the top level. So let me erase all of these things so that we can get again our diagram back. Yes, so this was original diagram. So initially, what for this, we have to maintain a queue Because we will be using BFS, breadth first search. I will be explaining why we have not used DFS. We will be using BFS. So one queue we will be maintaining and one map data structure to make sure that if I have encountered, for example, if I have achieved or I have got element at level 0, I won't be considering any of the elements present on the same level below the first element. So for that, to keep track of that, we will be using map. Okay, so first element that we will be pushing into the queue is root element. So A at a level of 0. Yes, and now we will be taking A out of it and 0. So as you can see, there is no element of level 0 in the map. So we will be just inserting 0 and A. Now is A is having left hand side? Yes. So we will be inserting B and level will be -1 because it is on the left hand side of the A. And is A is having right hand side? Yes. So we will be inserting just C, 1 because C is on the right hand side of A. Now we'll be popping out B. B level is -1. Is any element of -1 present? No. So we'll be just inserting B. Is there any left and right elements of B present? Yes. D. D is on left hand side of B. So D. Level of B was -1 and D is on the left hand side. So -1 -1. It will be -2. Similarly, E is present on right hand side. So E and -1 plus 1, 0. Just a second. Erase this thing. Yes. So now we will be taking C out of C. Level is 1. Is there any element present at level 1? No. We will be just inserting C. Any element present on left hand? No left element. But right element is present, F. So we will be inserting F. Current level of C was 1. F is on right hand side. So 1 plus 1. F at a level of 2. Yes. Now next element is D. D level is -2. So is there any element present of level -2? No. So we will be just inserting -2 and D. ये भी erase कर लेना था. Okay. Okay, so D, no element is present on left and right. So we'll be moving forward. Next element is E, 0. Is there any element of level 0 present in the map? Yes, 0. A is already present. So we won't be considering it. We will be rejecting because there is some another element before E which has been already taken place at a particular level. So we will be rejecting this particular element. Okay. Now next one is F. F2. Any element of level 2 present? No. So we'll be just inserting 2, F. Any left child of F? Yes. G. Level of F was 2. On one left hand side. 2 minus 1. 1. And any element of right hand side? Yes. H. Level of G was 2. Plus 1. 3. We'll be popping out G, 1. G, 1. Is there any element of level 1 present? Yes. C is already present. So we will be rejecting the element C. Get lost. And the last element which is present is where's cursor? Yes. H, 3. H, 3. Any element of level 3 present into the map? No. Just insert it. 3, H. So this is the final map that we have got. And as you know, map stores data in sorted form. So what we will be getting? Lowest level is -2. So D, then -1 B, 0 A, level 1 C, level 2 F, and level 3 H. So this is the answer that we'll be getting. And if you are able to notice, this is the top view of the tree. The 6 elements. This, and this. So yes, this was the main approach. And there is one thing given in the question. As you can see here, 50 and 70 both lie on the same level. ये मतलब थोड़ा दिख रहा है अलग, पर इसका लेवल है 1, इसका लेवल है 0, इसका लेवल है -1, इसका है 1, इसका है 0. So as you can see, both of them are lying on 0. If any such case, in such cases, if there are elements which are at same level, same level. And to whom you will give priority? We will be always giving priority to left element. It is given in the question. Hello everyone. So in there occurred some problem while recording, so the video got ended automatically. So I am recording the coding part for the second time, but no worries. Let us start coding part of the problem. So first of all, we will initialize a vector because we have to return vector in answer, vector int of ans, and we will be also declaring q of pair. And what will be the data structure? First part will be node and another part will be the level. So it will be q, and map will be integer m, q dot insert, and what will be inserting? Root and level 0, and while not q dot empty, node star node equal to q dot top dot first, int lvl equal to q dot top dot second, q dot pop. Yes, but there is one problem. It won't be q dot top, it will be q dot front. As it is q, it is not stack, so zoom it a bit. It will be q dot front, q dot pop. Yes, and if another if m dot find, if there is any element of particular level inserted, equal to m dot end, it means we are inserting element for the first time. Then m of level equal to node star data, मतलब जो ट्री का एलिमेंट है वो हम इंसर्ट कर देंगे. अगर पहले से एलिमेंट है तो हमें कुछ करना ही नहीं है. वी विल बी जस्ट मूविंग फर्दर. इफ नोड स्टार लेफ्ट, अगर लेफ्ट पार्ट डिफाइंड है, देन q dot insert q dot insert node star left. If node star right, q dot insert node star right. Yeah, after this we will be getting everything in map. So for auto it slash m ns dot push underscore back it dot second return answer. I think the code should run properly. Some error. q dot insert. ओके, क्यू में पुश होता है, इंसर्ट नहीं होता है. और q dot push, q dot insert, push. I think now it should run. q dot push root comma 0. क्या एरर है भाई? node star node equal to q dot front dot first. pair of node star आएगा शायद यहाँ पे. ओके, यहाँ पे गलती है, पेयर आएगा. अगर लेफ्ट साइड है तो LVL -1, इफ राइट साइड है तो LVL +1. now it should work. Yes, code is working. Let us submit it. क्या हो गया भाई? Okay. Yeah, as you can see, it is submitted successfully. Now this was for the case of top view. Abhi what for bottom view? कंट्रोल Z भी नहीं हो रहा है, कोई बात नहीं, चलो we take writing pad again. Now what for bottom view? बॉटम व्यू, अभी आप देखो टॉप व्यू में हमेशा फर्स्ट एलिमेंट जो था वो दिख रहा था, इसके नीचे कोई भी हो कोई फर्क नहीं पड़ रहा था। पर अभी इन केस ऑफ बॉटम व्यू किसी पर्टिकुलर लेवल पे जो लास्ट अकरिंग एलिमेंट है वो ही हमें विजिबल होगा। फॉर एग्जांपल यहाँ पे डी, ओके, अभी इस लेवल पे एक ही एलिमेंट है बी, अभी एट दिस लेवल देयर आर टू एलिमेंट्स ए कोमा ई, बट इफ वी आर सीइंग फ्रॉम द bottom side, the element last element on that particular level will be visible. For example E, C तो एक ही है, नहीं C और G दो है इस लेवल पे, बट बॉटम लेवल पे G विजिबल है, इस लेवल पे F एक ही है, इस लेवल पे H एक ही है। सो वी हैव टू डू इनवर्स। इन टॉप व्यू वी वर considering first element, but in bottom view we will be considering last element. So there will be only one change in the code, which will be okay. But first of all, understand which condition is in the code which is making sure that we will be considering only first element. Obviously, this condition. So I will be copying this complete code, return answer, and this is the question of bottom view. Let me erase whatever the code I have written here. We will be copy pasting the same code and I will be just returning this if condition. And let me run the code. I think this will work unless until there is not any syntactical error. Otherwise, conceptually, this is completely correct. As you can see, code is running. Let me submit it. And yes, working all the test cases. Because this was the condition of m of level, which in which we are making sure that only one element will be, or the only first element will be there from the particular level. But to overcome that condition and to insert only the last element of the particular level, we will be considering all the elements, and obviously for each level the last entry at particular level will be only of the last element present at the particular vertical level. So yes, code is done. Space complexity O of n, time complexity O of n. So I think this was enough for the top and bottom view. We saw code for both the problems. We had took examples of both as well. So I request you to all please try this question by you at home. And if any query, feel free to write in the comment section below. And if you like the content of the channel, follow the channel for more similar content. We will be meeting in the next video very soon. Till then, keep learning, keep hard working. Thank you very much.